Now that we're done with our loops demo, let's take a look at classes and methods. First, let's learn about creating a new class from within Visual Studio. Within Solution Explorer, you can right-click on your project, go to Add, and then go to Class. This should bring up a new dialog box where you can name your class. I'm going to jump straight to Visual Studio to illustrate this. Here in the Solution Explorer, we have multiple classes. Each C# file has a .cs extension. You can see I have address.cs, performer.cs, person.cs, and the main class program.cs. In order to add each of my classes, I would right-click on the project, click on Add, and Class, as you've seen in the screenshot earlier. As soon as I click on Class, I get to name my class. By default, Visual Studio gives me a name I could use, or I could just type over it, rename it to something else. I can click on the Add button here to add the class to my project. Since I've already added a couple of classes, I'll go ahead and click Cancel, and we'll switch back to my presentation to show you parts of a class. Within the parts of a class diagram, you'll see that I have multiple parts highlighted in red. Let's start from the very top. The class declaration shows you the public keyword followed by the word class, and then the name of the class. In this case, it's person with a capital P. Because it's public, this class can be accessed from outside our project as well. So if we build an assembly from our project, we can have other programs written by other people or written by you. You can access this class. If you have something private, it can only be accessed from within the class. So the person word is actually capitalized with a capital P. This is a convention that we follow. So if you had more than one word in your class name, you would also capitalize every word after the first word as well. Next, we have an instance variable. Each class can have one or more instance variable of any type. Here I have an integer that indicates my birth year. It's been initialized to 2014, but you don't necessarily have to initialize instance variables. The way instance variables work is that each person class can be used to create a person object. So you'll have multiple person objects for a person class, and each person object can have its own value for birth year. So person A could have a birth year of 2014, person B could have a birth year of 2010, and so on. Next, we have a property called AutoAge. Properties can have different blocks for get and set. Get lets you retrieve the value, and set lets you set the value. Notice that AutoAge does not have a set block. This means that it cannot be set by any code outside this class. The get block, however, returns a value. It says datetime.now.year minus birth year. So it's taking the current year, which let's say right now is 2015, and you subtract birth year from it, which has already been initialized to 2014, to return the value 1. So AutoAge always gets initialized to 1. But what if you want a different birth year? We'll learn about how you can use constructors to change it in a few seconds. But first, let's take a look at this other property called health. Health is also public. It is also of type integer, but it has two blocks, get and set. And you'll notice that we have a semicolon instead of additional code. So the get and set allows you to use health directly from a person object. So if you have person A as a person object, you can say person A.health to either use the value or to set the value. Next, we have two constructors. Constructors are special methods that have the exact same name as the class. So our class is called person. Our constructor is also called person. If you don't pass any parameters in parentheses, it means that you can initialize a new person object with this default constructor. Next, we have a person constructor that has a value that's being passed in. In this case, it's birth year. So we can create a new person and override the birth year that was being set to 2014 at the very beginning. So when you create a new person with this constructor, you can change the birth year for the person. On the right here, we have a public method followed by two private methods. Only the public method can be accessed from outside this class. In this case, the public method calls the two private methods, which happen to have the exact same name. This is called overloading. So you can have different methods with the same name as long as their signatures are different. That means that when you pass in values, the values have to be of different data types when you're calling them. So let's say I'm passing a number in this case, so it'll know that it can call the process value that has one integer value that it's taking in. If I pass in a string value, such as Xbox, it knows to call the last method here, process value that takes in a string. So do things helps you to hide the additional private methods called process value. It also shows you how you can overload each of these different methods by using the same name but different types. Now let's move over to inheritance and complex objects. In object-oriented programming, you can have a class inherit properties from another class. This is called inheritance. In our example, performer is inheriting everything from the person class. So performer is a type of person. Because they're in the same namespace, this allows us to easily inherit from this class. If they were in different namespaces, we would have to use a using statement to inherit the other namespace we're inheriting from. Anytime you use a different class from a different namespace, you would have to use a using statement to use them. Because performer is a person, a performer gets everything that the person class already has. Now, if you have different instance variables that are within the performer class, this is specific to performer. So every performer is a person, but every person is not a performer. We have two instance variables here called stage name and mailing address. Stage name is a simple string that is private. It can only be used inside this class. Mailing address is of type address, which we've defined here to the right. We'll get to that in a few seconds. But first, let's take a look at the performer constructor. So the constructor here takes two values, stage name and address. And it's initialized this.stagename equals stage name and this.mailing address equals address. When you say this, you're indicating that you're talking about this class itself, the instance of this class. So let's say if you initialize a new performer object, this.stagename talks about the current object. Stagename on the right talks about the local variable that's being passed in through this method. So the performer constructor here takes in stage name, and that value is being used to initialize this object stage name. Address is the same way. We're passing in an address as a parameter for the constructor, and we can initialize the mailing address constructor. Finally, we have a public method called getStageName, and this one actually returns the private stage name variable but adds additional things to it. This shows that you can have a private value, but instead of using it as is, you can manipulate it and do other things to it before you return it publicly. Off here to the right, we have a little description of what the address object looks like. So here we have a class called address, and it has multiple strings like line 1, line 2, city, state, and zip, and country. We also have a Boolean object, which indicates whether this address is a valid address or not. A Boolean can have two values, either true or false. All these string values up here can hold different text values. Since they're all getSet properties, you can use a new address and you can initialize each of these values simply by saying address.line1.line2 and so on.